This is a Calculus for Engineers presentation, and what we are looking at is inverse Laplace transforms. So what we're going to do is compute the inverse Laplace transform of the following expression. The given function of s, g of s, is s plus 2 divided by s squared plus 5s minus 6. Now, what we have here is a quadratic expression. The denominator, s squared plus 5s minus 6. What we would do there is factorize it. We would get s minus 1 times s plus 6. That's what we would get when we factorize that. So, the factorized denominator, I've just done it there. So what we get there is s minus 1, s plus 6. So we have the given function there now, here. And what we're going to do is expand this out a bit further to set it up in a format that's compatible with the tables. So s minus 1, s plus 6, and plus 2 times 1 over s minus 1 times s plus 6. Now, just be mindful of this 2 times that expression there. I'm going to bring this into play later on, but for the time being I'm going to concentrate on this expression here. Let's call it this expression here and this expression here. Later on I will mention this value 2 again. So what we're going to do is look at those two expressions I have circled in green, and these are forms that are well explained in the Laplace transform tables. The first, what we're going to do is look at table entries 8 and 9, and we're going to let a equal to 1 and b equal to minus 6. Table entries 8 and 9 essentially are of the form s over s minus a times s minus b, and 1 over s minus a s minus b. So if we let a equal to 1 and b equal to minus 6, then they sort of correspond to those forms. So let's move on there now a second. Let's look at the first term. We'll look at this term here first, and then we look at this term here second. I'm going to sort of disregard. I'm going to bring the 2 out of it and just have it 2 times 1. I'm just going to look at. I'm going to multiply it later by 2, but I'm just going to look at that expression just in the context of it being 1 divided by that. So, first expression, table entry 9 with a equal to 1 and b equal to minus 6. That's table entry 9 right there. So we would get a is 1 divided by 1 minus 6 to the power e to the t, or e to the 1t even, I'll just call it e to the t, minus 6 all over 1 minus 6 all to the power of e to the power of minus 6t. I'm going to simplify that now. I'm going to call that 1 over 7. 1 minus 6 is 1 over 7, or 7, e to the t, minus 2 minuses there, that minus and that minus cancel out, so we have plus 6 over 7 e to the minus 6t. Okay, so that's the first expression there. Now let's bring up the second expression there. So this one is a good bit simpler. 1 a minus b is actually again 7 times e to the t minus e to the minus 6t. Now just remember earlier I had 2 times this Laplace transform here. So what the answer we're looking for is actually 2 over 7 e to the t minus, I'm going to put the 2 over 7 here again, e to the minus 6t. Actually, I should probably put brackets there just to make it clear, and this without brackets. So we have these two expression, this expression here now. This is for the second term. So what we're going to do is put both of these together, for the first term and the second term, and this is now multiplied by 2. So combining the two expressions, we would have 1 over 7 by e to the minus t. So this expression here and this expression here, we can combine them as 3 over 7 e to the minus t. This expression here and this expression here can also be combined. So it's plus 6 minus 2 over 7. So we have plus 4 over 7 e to the minus 6t. Okay, I just spotted a mistake there. That should actually be plus 1 there. So that's a plus 1 there. So that ends our presentation. That's the answer there. And that ends our presentation.